Let's continue looking at section 7.3. So once again, we're going to use formulas involving sides, angles, and diagonals of polygons. So another refresher on what the formulas are. So remember, sum of my interior angles, n minus 2 times 180. All my exterior angles will always add to 360 degrees. And diagonals we get from taking n times n minus 3 and dividing by 2. All right, so it says find the missing angle measures. Notice that in this particular picture, I see 3 angles that are unknown, but notice that they are all marked the same. So if you want, while they have different variables here, you can just refer to them all as the same variable. So let's just call them all x. It is going to be important that we know how many sides we're dealing with. Remember, number of sides is the same thing as number of angles. So if I start at this angle, I'm going to start counting clockwise. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it looks like n equals 8 in this particular case because the number of sides matches the number of angles. So notice that since these are all angles, we can find the sum of these angles by using the formula n minus 2 times 180. I know that n is 8, so 8 minus 2 times 180 is going to tell me what all of those angles add up to. 8 minus 2 is 6. 6 times 180 is going to give us 1,080. So what I can do is I can add up all of those angles and set it equal to the 1,080. That's how I'm going to start solving for what I just then labeled as x, and that will find the angles that I'm looking for. So once again, I'm going to start at this angle, and I'm just going to go clockwise when I'm adding them. So x plus 130 plus 140 plus x plus 155 plus x plus 150 plus 160. Those are my 8 angles. Once again, they add up to 1,080. So we've got 3 x's. Now I'm going to add up all of those numbers. So 130 plus 140 plus 155 plus 150 plus 160 is going to give me 735. 2 steps to get x by itself. I'm going to subtract the 735. So that gives me 3x to equal 345. And then I'll divide both sides by 3. So it looks like each of the angles that I'm asking for is going to be 115 degrees. All right, here's our next problem. What is the name of the polygon if the sum of the interior angles is 3,060? So once again, sum of the interior angles, well, we know that formula. That is the n minus 2 times 180, just like we did in the last problem. Only this time, I don't know what n is. They are telling me 3,060 is going to be represented as the sum of my angles. So this is a working backwards problem to solve for n. So it's going to be 3,060 is going to equal n minus 2 times 180. So remember, I want to get rid of that multiplication first. So the opposite of multiplication is dividing. So 3,060 divided by 180 gives us 17. That still equals n minus 2. Last step to solve for n, I'm going to add both sides. So then n equals 19. Once again, that's not my final answer either because it says what is the name of the polygon. 19 would then become a 19-gon. And that is the name of the polygon that has 3,060 degrees for the sum of my interior angles. Here I want to name the polygon that contains the following number of diagonals, 135. Remember, if we're talking diagonals, our formula for diagonals is n times n minus 3, all divided by 2. This is another working backwards problem because they are telling us what the diagonal is. They are not giving us the number of sides. So we're going to set it up as 135 to equal this n times n minus 3, all divided by 2. So to get rid of that division, I'm going to multiply both sides by 2 first. 2 times 135 is going to give me 270. That's going to equal me distributing the n from the numerator. N times n is n squared. N times negative 3 is negative 3n. I want to get everything to one side. I'm not going to move that positive n squared, which means the 270 gets moved over to the other side by subtracting. We still have an equation, so now it's 0 equals, no like terms on the right, so n squared minus 3n minus 270. With there not being a number other than 1 that all of those numbers have in common, and with not every single term containing a variable, there is no GCF, which means we are asking ourselves what is going to multiply to the last number, but add to the number in the middle. So we're looking to create a table. I know that because we want to multiply to a negative, we're going to have one of each. Okay, so I'm trying to think about numbers that multiply to negative 270. Well, negative 27 and 10 will multiply to that. But notice that when I try to add those, I'll get negative 17, which is not the number that I want in the middle. I need to pick two numbers that are closer to each other. Well, if you go down the list, another way to multiply would be a negative 18 and 15. And notice that when I combine those two, that will give me a difference of negative 3. So that checks out where these are the two numbers that need to be used. So when I'm creating my factors, where it's still going to be set equal to 0 because we still have an equation, I have to start each of my factors with n because n times n is n squared. We'll be then dealing with a negative 18 in one of the parentheses and a positive 15 in the other. I will set each of those that contain an n equal to 0, which means we are adding 18 over to the other side and subtracting 15. So we have two different values for n, positive 18, negative 15. Because n's representing the number of sides, there's no such thing as a negative number of sides, which means 18 is that number. To name the polygon, it would become an 18-gon. Okay, if we look at this problem, it says, what is the sum of the exterior angles of this figure, ABCDEFGH? Okay, so notice that we've got a pretty big figure here, but if we're talking about sum of exterior angles, hopefully we remember that there is the formula, sum of my exterior angles, and it's not so much a formula as it is just a number. It does not matter how many sides. I didn't even technically have to draw this picture. No matter what, I didn't even have to give you a polygon. I just could have said, what is the sum of exterior angles of a polygon? And your answer, no matter what, is going to be 360 degrees. So that's us using formulas involving sides, angles, and diagonals of polygons.